Hi everybody, in today's videos, let's look at diffractions. If you are standing in front of the mirror, you will see an image inside the mirror, right? So you are the object. The person inside the mirror is the image. The mirror is acting as an axis of diffractions. You will notice that if you are wearing a watch on your left hand, you look at the person inside the mirror. He is actually wearing a watch on his right hand, laterally inverted. So same thing happened here for diffractions. Okay, let's look at this example. Now I have a triangle ABC. Let me draw the axis of diffraction first. So for a diffraction, we need an axis of diffraction. Same thing, when you want to describe a diffraction, you need to mention the axis of diffractions. So now, I am going to diffract this triangle ABC across this line. So this is the object, this is a mirror, the image will be somewhere around here. Okay, so this is the image. Normally, we will just label the vertices of the image using the same letters as the object, but we add a prime on the top here to indicate that this is the image. So here, at this point is the image of this point is the image of this point. So do you notice that they are actually congruent? They have the same shape, same size, but their orientations are different. You try to look at the orientations. This is A, B, C, clockwise. This is A prime, B prime, C prime, and D clockwise. Okay, so this is one of the properties of diffractions. Now let me show you what will happen when I move this axis of diffractions. When I move this axis of diffractions, the image will move as well. So the positions of the axis of diffractions is going to determine the locations of the image. So you see, when I move, if I place it horizontally, like this, the image will go here. Make it closest to the object. Right, so this image will move up as well. Okay, so do you notice that the perpendicular distance from one point to the axis of diffraction is the same as the perpendicular distance from the corresponding point to the axis of diffraction. What do I mean is B to axis of diffractions is the same as B prime to axis of diffractions. So here is 1, here is 1, right? So same thing apply here. 1, 2, 3, 4, 5. How about here? 1, 2, 3, 4, 5. Okay? So now let me move that way. Okay. Make it closest to this object. Okay, let's try. 1, 2, 3, 4, 5, 6, 7. So the corresponding vertex will be C prime. 1, 2, 3, 4, 5, 6, 7. Okay, so this is also the properties of diffractions. If I have a triangle here, ABC, I want to draw, the question asks us to draw the image of the triangle when this triangle is diffracted across this line. So the image will be somewhere around here. But in this case, we don't have a small square grid given to us, so we cannot calculate. So what should we do? How do we draw the image of this triangle? So we need to use a compasses to help us. So how to do is actually very simple. You place the compasses over here at this point, A. So now I am going to draw the image for this point. Okay, let me use red color. So the length here, any length is okay. as long as the length can cut here, and then don't too small, because too small you are not able to cut this axis of diffractions. So okay, how about I open this wide? So here, make a cut here, make an arc here, then move over here, make another arc over here, and then remember, don't change the width of your compasses. Place this over here. Okay, then make an arc over here. Do the same thing here. Okay. So here, this is the image of this point, A prime. So you repeat the same thing for B and C. Okay, let me show you B. Okay, let me change the color. Same thing here. The length here, any length, but don't too short. Okay, how about I use this length? Should be okay. Okay, here cut, make an arc here, and then here do the same thing, make an arc. And remember, don't change the width of your compasses. Move it over here, place it over here. Okay, make another arc, and then move down to this point. This intersection point, do the same thing, make an arc here. Okay, so this is the image of point B. So I will label it as B prime. So do the same thing for C. Sometimes if this is not, the length of this axis of diffraction is not enough, you can actually extend it using a ruler. So let me try the last point. Let me use black color. Okay, place over here. Okay, so make an arc here. Do the same thing for this part. Make an arc here. And then move it over here. And remember, don't change the width of your compasses. Place it over here. Make an arc. And move it down here. Make an arc as well. Okay, so this is the last point. This is C prime. So the next step is just connect all these points together. Just connect all these points together. So maybe some technical error, so it's not perfectly straight. Okay, but this is the way how we draw the image. Well, let me draw it again. Okay, should be here, right? Here to here. Okay, then go this way. Oh, go up. Okay. So this is the image of this triangle. So let's say you are not given the small square grid and you are asked to draw the image. You need to use the compasses. So that's the way how we draw the image. Okay, so how about sometimes the questions give us the object and the image, and the question asks us to draw the axis of diffractions. Okay, so let me erase this axis of diffraction and let me show you how to draw this. Okay, now we have the object and we have the image, and the question asks us to determine the axis of diffractions. Same thing, we need to use the compasses to help us. Here we have 3 points, A, B, C, and here another 3 points, A prime, B prime, C prime. What you need to do is choose one pair, A and A prime, B, B prime, or C and C prime. You just need to do the perpendicular bisectors of one pair of this point. So for example, let's say if I choose B and B prime, I want to break this line this way, perpendicular bisector. So what do I do? What do I need to do is take out your compasses, place over here, any length, but don't too short, because we want to, it's preferable more than half of that B and B prime. If it's too short, later on you cannot get the intersection point. Okay, cut it here, here. And repeat the same thing. Don't change the width. Place it at B prime. So if just now I use B, then the second point I have to use B prime. If the first point I use A, the second point I need to use A prime, corresponding point. So here make an arc, here also make an arc. Okay, so now we have two intersection point, right? This and this. What we need to do is connect this to all the way up. Okay, and then label it. Oh, new color. Oh, let me change it. So this is the axis of diffractions. Okay, let's look at this example. Another questions. The triangle A prime, B prime, C prime, this triangle is the image of a triangle ABC under a diffraction T. Describe the diffraction. So remember, to describe a diffraction, you need to mention the axis of diffractions. In this case, actually you don't have to use a compasses. You also can know where is the axis of diffraction, right here. So let's say if you cannot get it, we just use the compasses. Sometimes we don't have to use the compasses, just by looking at it we know, because this the middle point will be here, right? So this will be the axis of diffractions. Okay, let's say that we cannot get it just by looking, and we need to use the compasses to help us. So how to do that? So remember what I told you just now. Choose one pair of the corresponding point and the vertices. Sorry, one pair of the point. It means that B prime, C prime, A prime. So any pair. Then use the compasses. Construct a perpendicular bisector of this point. Over here. Then do the same thing here. Remember, don't change the width. Okay. And the next step is just connect these two points together. Okay, so this is the axis of diffractions. This is the axis of diffractions. So how do we describe this diffraction? So T is a diffraction in the line. Okay, so now I'm going to tell the axis of diffraction. How do we tell people about this line? So do you notice that the y for any point fall on this straight line always will be 7. This is 1, 7. This is 2, 7. This is 3, 7. I mean the coordinates. And this is 4, 7. This is 5, 7. So the equation of this straight line will be y equal to 7. So T is a diffraction in the line y equal to 7. So this is the way how we describe a diffraction. We need to mention the axis of diffractions. Triangle A prime, B prime, C prime is the image of triangle ABC under diffraction R. Describe the diffraction. Remember, when you are asked to describe a diffraction, you need to mention the axis of diffractions. So how do we get the axis of diffraction? Same thing, use of compasses. But in this case, actually, we don't have to use the compasses. You also can get the axis of diffraction, right? Okay. So let's say if we want to use the compasses to help us, we choose any 2 points. B prime, A prime, or C prime. So in this case, I think I will just choose B and B prime. Bring an arc here. Do the same thing for this part. And move it over here. B prime. Bring an arc. Here do the same thing. Okay. So the next step is just connect these 2 points together. So this is the axis of diffractions that we are looking for. Axis of diffractions. Okay, now since we already got the axis of diffractions, we can describe these diffractions. R is a diffraction in the line. Okay, now I'm going to tell the axis of diffraction. How do we write or mention this straight line? So do you notice that any point that fall on this straight line, the coordinate, the x coordinate, this is 7, 1, right? This is 7, 3. This is 7, 4. Every time the x coordinate will be equal to 7. So this straight line is x equal to 7. This is the equation of this straight line. So if you tell people x equals 7, then people know that you are mentioning about this straight line. Okay? Okay, so now let's look at another example. Now triangle A prime, B prime, C prime is the image of this triangle. We want to describe these diffractions. Same thing for describing a diffraction, you need to mention the axis of diffraction. So some students in this case, right? So if you want to get the axis of diffraction just by looking at it, we also can get the answers. But sometimes it's a little, let's say, if we are not able to get the diffractions just by looking at it, so we need to use our compasses to help us. So I think this time it should be no problem how to determine the axis of diffraction, right? Okay, so choose any 2 points, B, B prime. If you want to choose A, then you have to use A prime. C, you have to use C prime. If let's say first point you choose C and second point you choose B prime, oh no, this is not correct. B have to, how to say, B, if you use B, you have to, the next point you have to use B prime. Okay, I hope that you get what I mean. So for example, in this case, I would choose B. Okay. Okay, then place over here. Okay, and then do the same thing for this part. Okay, so the next thing is let's connect these 2 points together. Okay, so if let's say if you want to extend it, okay, let me try to extend it. Okay, so this is the axis of diffractions. This is the axis of diffractions. But now, when you come to describing this diffraction, some students might face some problem. So for example, now let's say, okay, I want to describe these diffractions. R is a diffraction in the line. Okay, so how do we tell people about this line? So if you are in Form 3, then you have no problem. Or if you are in Form 5, you have no problem because you know how to find the equation of this straight line, right? So let's say if you are in Form 2, you haven't learned about the method of finding the equation of a straight line. So how do we tell people about this straight line? So you can choose any 2 point which lies on this straight line. You can do this way. R is the diffractions in the line passing through. Okay, let me use another color. So this is slightly different from just now. It's not y equal to what or x equal to what. This is actually in the form, if you want to write this equation for this straight line, is y equal to, it will be in the form y equal to mx plus c. Okay, so since as I say you haven't learned about that, so how do we tell people about this straight line? In the line passing through GH. Passing through, okay, just give 2 points that fall on this straight line. So we can say, how about 0, 0? And another point, how about we choose 11, 11? Because to draw a straight line, you just need 2 points. If you mention 2 points that fall on this straight line, then people know that which line you are telling. Okay, so R is a diffraction in the line passing through 0, 0 and 11, 11. Not necessary you have to choose these 2 points. You can choose other 2 points, for example, 2, 2 or 2, 2 and let's say 10, 10. Okay, so let's say you have learned how to get the equation of a straight line, so you can describe it another way. Okay, now let's try. How do we find the equations of this straight line? So remember, if you want to find the equation of a straight line, you need 2 things, gradient and 1 point, and the point must lie on the straight line. Okay, so how do we get the equations? Let me show you here. Let me use this color. We know that the form of the equation of this straight line will be in this form: y equal to mx plus c, and m is a gradient, and c is a y-intercept. So in this case, y-intercept means that, let's say the straight line goes this way. Oh, okay, forget about this. If the straight line goes this way, cutting the y-axis at 7, so the y-intercept will be 7. If let's say if the line goes this way, cutting the y-axis at 10, so the y-intercept will be 10. So in this case, the y-intercept is equal to 0. Okay, first let's find the gradient of this straight line first. To find the gradient, we need 2 points, right? So how about I choose this point and this point? So this point will be 7, 7. And this point will be 4, 4. I hope that you still remember the formula. y2 minus y1 divided by x2 minus x1, right? 7 minus 4. Remember, y on the top, x at the bottom here. So this is 3, you get 1. Okay, so 1 is a gradient. Y equal to 1x plus c. Y equal to 1x. 1x, you don't have to write 1, you just write x. People understand that there's 1 in front of here. Plus c. So in this case, you look at this straight line, you know, okay, c is equal to 0. Let's say if you don't know, you want to find, then we can use any 2 points that lies on this straight line to help us to get the c. That's why just now I told you that to find the equation of a straight line, we need 2 points. We need gradient and 1 point. Now we have found the gradient. The next thing is to get 1 point, substitute into this equation to help us to get the c. So how about I choose 4, 4. At point 4, 4. So y will be equal to 4. X will be equal to 4 plus c. So c is equal to 4 minus 4, which is equal to 0. So we know y is equal to x is the equations of this straight line. So in order, instead of describing this straight line this way, passing through, you give 2 points, you actually can describe in another way. R is a diffraction in the line y equal to x. Then people know that you are telling about this line. Okay, so for this video, I think I just stop here first. So I will continue doing diffractions for the next video. See you next time, and thanks a lot for watching. Bye bye.